and welcome back. Today we are going to be looking at factors affecting the stability of anions, which are also conjugate bases. So let's get on to the first rule. First rule says which atom bears the charge. So let's look at two examples, butane and propanol. Alright, so here's butane and here's propanol. Notice how in butane, this hydrogen is attached to a carbon, but in propanol, this hydrogen is attached to an oxygen. So now we have to compare which one would be more stable and which one would be more acidic or basic. Well, notice how carbon and oxygen are in the same row on the periodic table. So electronegativity is the main effector. So the proton on the oxygen would be more acidic than the proton on the carbon because oxygen has a higher electronegativity than carbon. And the second factor that we're going to be looking at is resonance. So remember, resonance is the way that we use to compare or to solve the issue of bond line structures being inadequate. So which base is more stable and therefore less acidic? Would it be the one with resonance or the one without resonance? Well, the answer is it's the one with resonance because the resonance is the thing that stabilizes it. The third factor that we'll be looking at is induction. So let me draw out two molecules that look very similar. Alright, so one of them is acetic acid and the other one is trichloroacetic acid. So what are these chlorines doing here? What is chlorine known for? Chlorine is known for being extremely electronegative, just behind fluorine. So what are they going to do? Well, yes, they are going to try to steal as many electrons as they can from that carbon, which, by the way, isn't drawn because it's a bond line structure. So, therefore, the Cls are going to be getting more of the electrons, therefore leaving this molecule to be more stable and therefore more acidic. Alright, the last and fourth one we're going to be looking at is orbitals. Which one is more acidic and, well, which one's more stable and therefore more acidic? Let me draw out three molecules for you. Alright, so there are the three molecules we have here as a single bond, and this one is ethylene with a double bond, and this last one is acetylene with a triple bond. So, which one is going to be more acidic? Well, this all depends on the orbitals. So, when they have a single bond, for single bonds, remember what it is? It's sp3 hybridization. So this one has sp3, sp2, and sp. And this is actually the order of increasing stability and therefore increasing acidity. So this one with the single bond is going to be the most basic or the least stable and least acidic. This one's going to be kind of in the middle, and then the acetylene is going to be at the top, being the most acidic and most stable.